Okay, this is chemistry 314.
Guess it's Pi Day today.
14, it's also Einstein's birthday.
It's Pi Day and we did not bring any pie in?
My sister made the...
So we'll take number 29 first. On number 29, what always freaks people out is where it says 20.9% oxygen in air. Ignore that until the end. So can you write a balanced equation for, I keep doing this, the combustion of octane?
Yes.
Did you already do that?
Yes.
Do that first. Once you have the equation for octane, is air a reactant here? Is air a reactant here? No. Oxygen is. So what you need to figure out is how many liters of O2 are required. Once you get that number, you know, and I'm going to make up a number here. If you require 713.6 liters of O2, and you know that there are 20.9 liters of O2 in every 100 liters of O2, can you solve for how many liters of air, whoops, that should be air, for how many liters of air you need at that point? Okay, so that's really what you need to do. That's where that 20.9 comes in. Questions, or does that clear it up? Okay, when you're looking at that reaction at number 31, liquid nitroglycerin exploding, you're only given one reactant. That's the nitroglycerin itself. So what kind of reaction is this? Decomposition. You have one reactant turning into a bunch of products. Okay, so there are all your products, and those are given in the problem. The only clue that I'm going to give you is that the coefficient on the nitroglycerin is 4. So from there you should be able to balance everything else. So in number 31, we're given the reaction, and we're told that 5.00 times 10 to the second grams of nitro exploded STP, and we want to know what the total volume at STP is for all the gases. So you're starting off with the mass of a liquid in this case. It's not a solid, but still it's not a gas. And you know that you want to end up in the volume of a gas, and we know that this is occurring at STP, so we need to go grams to moles, and this is going to be nitro. And then we're going to go moles nitro to moles of our first gaseous product. For moles of our gaseous product at STP, do we have a way to get to liters of a gaseous product? Yes, we do. And you're going to do 4 factor labels, one for each of these products, and add them up. Okay, so hint for number 33, once you balance that equation, remember you're starting with a mass of a solid. If you go over to moles of your acetylene, then you can plug that into the ideal gas law, making sure you adjust for partial pressure of water. Okay, so that's what we're given. We'd like to know what the excess is. You can do a straight up volume ratio. So start with one of your givens, go to a volume of the other given, and compare the number you get to the amount that is stated in the problem. That's all it takes. And it's just like doing a mole-to-mole limiting an excess problem, except you're able to use the coefficients as mole ratios.